Okay, good morning. So we are going to continue. We talk about the concept of the limit the other day. Okay, so we give you various examples. So we are going to continue with those examples to finish them. So basically, let me just go to my notebook. We give you different methods, but the method that we're going to use in order to find the limits based on the so-called computing theorems. That's a theorem that enabled you to apply the notion of the limits to the various combination of functions. Okay, so this is just reminder the theorem that we have. This is our tool. Okay, so that enable us to find the limit of the sum of two functions. So this means the operation of the limits and those addition, subtraction, multiplication, division operations computes, we switch it. But eventually we get to this famous result, number 6. And number 6 is if a function is a polynomial function, just combination of powers of x. So direct substitution would be the result. Most of the time, you combine number 6 with the others in order to be able to find your limits. And number 7 is going to be used for the piecewise defined function. When the equation of a function is partitioned, then at the partition point, you have to find the right and the left limits. So if the right and the left limits are the same, so that gives you the limit of the function. Okay, so we are going to continue. So I started over. I just give you a couple of them the other day, but I like you to have all of them in one set. So we're just refreshing your memories, and then we do it again. Okay, so that was the one that we did the other day. So I'm going to give it a similar one. So there you are. And all of them are going to be questioned in your first quiz and the first test. Okay, so we are going to continue. So this is Wednesday. So continuing with finding each limits again. Okay, example. Find each limit. Okay, this is it, the first one. The first one is like a polynomial type. So it's a limit of 3, for example, 3x to the 5th minus x plus 2. And you want to find this one when x goes to a -1. Okay, we talk about it. This is a polynomial function because it's a combination of powers of x. So to find the limits, we're just using direct substitution. Okay, so the solution is going to be, so you just give it starting with the function. You can do it here as well. So I want to find the limit of the 3x to the 5th minus x plus 2 when x goes to -1. So substitute carefully. 3 times -1 to the 5th minus -1 plus 2. -1 to the 5th would be -1 times 3 would be -3. Double negative make it to the positive and the positive 2. So the result would be 0. So the limit of the function, you don't have to repeat it, but I do. 3x to the 5th minus x plus 2 when x goes to -1 is equal to the 0, and we are done. That's a type 1. Any question? So in type 1, polynomial. When you have a polynomial, the limit of the function and the value of the function got to be the same. It's like in algebra. So we get the direct substitution and be done. Let's say case 1. Ready for the case 2? Case 2. Kind of a radical function. So for example, the limit of the square root of 4x plus 1. 4x plus 1 when x goes to 2. Okay, we have a radical function. Okay, we have a radical function, And we talk about it. If you want to find the limit of the radical, you have to take the limit inside. When you take the limit inside 4x plus 1 is a polynomial, and the direct substitution gives you the result. So we'll let you do it quickly. So this is going to be the solution. So basically, the limit of the 4x plus 1 when x goes to 2, again, the direct substitution gives you the result. It's going to be 4 times 2 plus 1. So 8 plus 1, that gives you 9. The radical 9 would be 3. So the limit, okay, for x plus 1 when x goes to 2 is simply equal to 3. And we are done. Okay, so for the limit of the radical, if you stay outside of the radical, you can't do anything about it. So you have to go inside. We go inside the radical. Inside the radical, we have a polynomial. Limit of a polynomial is the direct substitution. Is the same as the value of the polynomial, okay, value of the function. So we substitute, get your result. That is case 2. Any question? So that would take us to the a little bit more tricky one. Number 3, rational function. This is where we are going to manage many choices, or 5 different choices. So pay attention. So it's going to be limit of what? This is 7x squared. 7x squared plus 8x plus 1. And you divide it by x squared plus 5. But x goes to negative 1. Again, is a quotient function. For finding the limit of a quotient function, you have to find the limit of the top divided by the limit of the bottom. But the top and the bottom are polynomials. So in order to get the limit of a polynomials, direct substitution. So simply you directly substitute for x equal to the negative 1, and you get the answer. Okay, so this is it. Solution. This is the way I do it. I repeat it again, but you can substitute right away. Is a 7x squared plus 8x plus 1 over x squared plus 5. X goes to negative 1. Substitute carefully. So that gives you 7 times a negative 1 squared plus 8 times a negative 1 plus 1. And this is going to be negative 1 squared plus 5. So stay on the top. Negative 1 squared would be positive 1, so that gives 7 on the top. Minus 8 plus 1. Negative 1 squared would be 1, 1 plus 5. So 7 minus 8 would be negative 1. Negative 1 plus 1 would be 0. So the top would be 0, the bottom one would be 6. 0 divided by 6 would be 0. So the limit of the function is 0, and be done. Okay, on the test, some people, they stop here. You are not done. The 0 is the final answer, not 0 divided by 6. Okay, so that's a case 1 for the rational function. X squared plus 8x plus 1 over x squared plus 5. Again, I repeat it so I get it, but that would be accepted. So that's a case 1 with the rational function. Any question? So far everything is nice when we direct substitute and we get our answer. But it's not going to be the case all the time. So that will take us to the part 2 of the rational function. We have 4 different types. Okay, are you ready? I'm going to go to the next page and give you that last idea that we discussed the other day. That was the case that it's a rational function. You want to find the limits, but when you directly substitute, you arrive at the, okay, then you arrive at the 0, 0. So that was the case that we have to consider again. So that is the 4th one and the important one here. This is different. So let's see what is different about this one. So it's a limit of 5x squared. Okay, 5x squared minus 4x minus 1 and divided by x squared minus 1. It's the one we discussed the other day, but we want to do it again. Okay, so as usual, we have polynomials all over the places. So we directly substitute to see if we can get the answer. Okay, so the solution is going to be, this is a solution. So I have the limit of, it's a 5x squared minus 4x minus 1. I just repeated, but you don't have to. Directly substitute. If you put the 1 on the top, that gives you 5 minus 4 plus minus 1, and that would be 1 minus 1. So on the top, we get 5 minus 5, which is going to be 0. And on the bottom, we get the 0. That's it. Okay, we talked about it the other day. 0, 0 is called indeterminate form. You see, this is going to be indeterminate. Okay, it's an indeterminate form. So this means there is going to be a solution, but we cannot determine what is going to be the result for the time being. Now, the way we are going to do it at this level, and on the test, you are not going to use anything else. We talk about it. The reason that we get 0 on the top is that x equal to 1, if you like, is the solution of this polynomial, if you like, if you let it equal to the 0. Anytime we get a solution, that creates a factor for you. So this means the top can be factored, and x minus 1 is a common factor of the top. It's the same thing for the bottom one, which is easy, x minus 1 times x plus 1. So as soon as we get the 0, 0, you remind yourself that x minus 1 is a common factor. So you have to find it and eliminate it. So you have to repeat your operation again. So the operation is going to be, you repeat the first one, limit of x goes to 1. Okay, x goes to 1. So the top would be 5x squared. I just repeated. X squared minus 1 is equal to the limit of x goes to 1. You want to factor it, but you already got one common factor. That common factor is x minus 1. So that's x minus 1. And that would be x minus 1. So we have to find the other end, the other factor, if you like, other factor. Now, over here, you see you have 5x squared. So this is x, so you have to put the 5x there. You see, 5x times x, 5x squared. Then you create the number, the constant term is -1. So -1 times what would be -1? -1 times a +1 would be a -1. Okay, the bottom one is easy, x minus 1 times x plus 1. This is how we're going to factor it. Any question? So don't know, we know that, in algebra, the way you factor this one, you break the middle one using grouping method. But since you already got the common factor, if you pull out this common factor, so you'll be able to find the second one quickly. It's a kind of shortcut to be able to do it. Okay, so x goes to 1, x minus 1 is a common factor. If x goes to -1, x plus 1 would be a common factor. So you put your common factors on the top and easily you can find the other ends. So now this is the time that we can divide by x minus 1 and x minus 1. So the leftover is going to be the limit of 5x plus 1, x plus 1. X goes to 1. Now direct substitution give you 5 plus 1 on the top, 1 plus 1 down the bottom. So that gives you 6/2, which is equal to 3. So the limit of the function, the limit of the 5x squared minus 4x minus 1 divided by x squared minus 1 when x goes to 1 is simply equal to what? Is equal to 3. And you're done. Very nice format, and you've got to be careful about it. Any question? The way you write it down is important for us. You see, as long as there is an x, you have to keep the limit, especially when you cancel out this. If you don't put the limit here, you can't do it. The reason is you divide by x minus 1. So you must make sure that the x minus 1 is not equal to the 0. If you put the limit, we talk about it, x goes to 1 means you estimate x. So this means x is not equal to 1. It's close to 1. So x minus 1 is not 0, you can simplify it. If you don't put the limit, you can't simplify it. Because how do you know that x is not equal to 1? Okay, so if you do it on the test, you may lose some points if you don't have the limit here. We put the question mark for you. Just make sure that you know this side, this form. And again, as long as there is an x, you are not done. Limit. The only part that you drop the limit is when you substitute. So make sure that you know, don't lose any point on this one. Any question?
Yeah, I have a question on the test. I don't know if you already said this. Maybe I just want to clarify.
Yeah.
Do we need to work out the first solution to show you it's indeterminate, and then we do the like common factor or whatever else? But do we first work out the zeros over zero?
It would be better to check it, but
Okay.
otherwise you can do it. Yeah, we don't mind.
Okay. So
Checking one is, you know that it may be case 1. You see, it may be the case that, you know, you'll be able to find it.
Yeah. Okay.
That's why we check it, but otherwise, no, you can do it right away.
Okay.
On the
Okay.
test,
Yes.
when you're showing your work, do you require us to have the limit before every section of work, or will you take points off if I don't write limit? Like
These limits, you mean?
Yeah.
Oh yeah.
Okay.
You will miss quite a lot if you drop it.
Okay.
Because you see, as I talk about it, this part, when you get to this part, you want to simplify it. You have to guarantee that x is not equal to 1. Otherwise, you can't do it. If you put the limit, you know that the limit means x is not equal to 1. So you can simplify it. So that would be, you know, that would be very important part. And, you know, the way we write it down is, this is it. Yeah, you have to write it down. You know, keep the limit. Otherwise, you'll be in trouble. You will lose a point here. Okay, if you don't write it. Or it doesn't make sense. It's a limit. The only time you have to drop the limit is when you find it. So, you know, write as I did it here. Okay. Any question? That's a type 1. The type 1 that it's a 0, 0, but you have polynomials on the top and the bottom. And there's going to be the type 2. It's the 4 types and you get all of them. What's going to be type 2? We start with the mild one and then we come back and we make it better. So this is historically, again, very popular problem. And we extend it. It's a radical x minus 2 over x minus 4, and x goes to 4. What is the one that they call it type 2? The type 2 is on the top, you get a radical. You see, if you substitute, so the solution is going to be, again, you know, the direct substitution is available for all of them because of the theorem that we talk about. So I'm going to test it. Same thing. Okay, that's it. You can test it here right away. So if I substitute, you see, as soon as I substitute, I drop the limits. Is a radical 4 minus 2, and that's going to be 4 minus 4. Radical 4 would be 2. 2 minus 2, this is 0. We get 0, 0 again. You see, that is going to be the case. So again, 0, 0, there is a message. What's the message for this one? Any suggestion? We know that you have a common factor. What is that common factor for this one? The common factor.
Would it be x minus 4?
Excellent, that's it. So x minus 4 is a common factor because x goes to 4. You see, if x goes to 4, so the common factor would be x, okay? The common factor would be x minus 4. So it depends on this number because you substitute. So you make a note for yourself that x minus 4 is a common factor. A common factor. So you have to find it. You have to create it. You see, the bottom one, you already got x minus 4. But you have to create it on the top. The top is not a polynomial, it's a radical expressions. This time, in order to create it on the top, remember we have something in algebra, we call it rationalizing the expressions. Rationalizing means removing this radical. So in order to remove that radical, we multiply the top and the bottom by the conjugate of the top. Conjugate means you change the sign. It's a radical x minus 2, so the conjugate would be radical x plus 2. So you multiply the top and the bottom by the radical x plus 2, automatically you will get your x minus 4 out. Okay, so this is the one we call it case 2. And you do this one quite a lot. And especially if you want to take calculus 1, 2, especially in 3. In calculus 3, we do this one for the function of 2 variables or 3 variables. So it's a very important procedure. Okay, so there are, you have to rewrite it again. And we can do it right at the beginning, we don't mind, because this would be clearly the case. So you can start from here, even we don't mind. You see, this is it. You have the radical x minus 2. You have to multiply by its conjugate. Conjugate means you're just changing the middle sign. It's a negative 2, it's going to be positive 2. That's a conjugate. But you have to do the same thing to the bottom to balance it, if you like. X minus 4, again, that conjugate. That's it. Any question? Remember, you are looking for x minus 4 as a common factor, x minus 4. Down the bottom, you have the x minus 4. So you're not going to do anything to the bottom. On the top, multiply it. It's a special product. A minus b times a plus b. Remember this theorem? A minus b times a plus b is equal to what? Is equal to the a squared minus b squared. So this is the way you're going to multiply the top to simplify it. So it's going to be, you get equal to the limit of, I just explain it, you can do it right away. The square of the first one would be radical x squared is like radical x times radical x minus the square of the second one, 2 squared. Remember the bottom one, you are not going to do anything to this. You keep it because you need that common factor. X goes to 4. Okay, I'm just using the special foil. So we'll continue on the top. So it's going to be limit of x goes to 4. Radical x squared would be x minus 2 squared would be 4. The bottom one as is, x minus 4 times radical x plus 2. Now we have a common factor that we are looking for, you see. So divide by x minus 4. The leftover on the top would be 1. So you have the limit. Again, you keep the limit all the time. So we get 1 on the top and the radical x plus 2 down the bottom. Any question? Now you remove the x minus 4. So you just substitute x equal to 4 and you get your result. So it's going to be 1 over radical 4 plus 2. Radical 4 would be 2. 2 plus 2. That give you a quarter. So there you are. It's a limit of radical x minus 2 over x minus 4. X goes to 4, and this is simply a quarter. You see? In future, when we get to the next chapter, what you did over here, you just find the slope of a tangent line to the graph of y equal to the radical x at the point with x equal to 4. Or in future, this is the derivative of the radical x when x is equal to 4. So you are going to see this one. That's the reason we discuss it here, and we want you to, to be prepared. So this problem is going to be used 3 more times in future. Very important techniques. Any question? So you should be able to carry this one. You will see it on your quiz and the test. And so the first thing to do is just checking. Just have a look, checking this is a 0, 0, because you may substitute get the result. You may get 2 different numbers, but we just check it to make sure you get the 0, 0. When we get the 0, 0, so there must be a common factor. You find that common factor, x goes to 4. So the common factor is x minus 4. You already got it on the denominator. You have to create it on the top. The previous case, we factored it, but this is a radical expressions. So for this radical expression, in order to get that x minus 4, you multiply the top and the bottom by the conjugate of the top. Conjugate means you change the sign here. So you have radical x minus 2. So you multiply by radical x plus 2. But you have to do it top and the bottom at the same time. Down the bottom, you are not going to change anything. You keep it as is because you need that x minus 4. On the top, you have to continue. Use a special FOIL product. The radical x times radical x squared, 2 before, and you can do it right away. So that gives you your x minus 4 that you needed. Now you divide by x minus 4. The leftover is 1 on the top. Okay, so you just substitute. You get a quarter as the final answer. That is case 2. Any question? Now, and this is, it's not bad, but the one that mostly you may get in future, and you are going to get in 3 places, is going to be a little bit more of algebra involved. You see, this x is too easy. Radical x, it's just in general. We have another famous theorem in future. We call it the chain rule. And that's going to be the formula for finding the derivative or finding the slope. For that type of problems, at this time, you need this procedure. So I'm going to give you that one. It's a little more details involved, okay? So let's see if they want to make it more exciting for you. They give you this one. So this is going to be our number 6. And it's a very important problem again. So you will see it up to the test 1 3 times. So let's see what is this example. You want to find these limits. Look at this. You want to find the limit of, just I bring more algebra involved. So I have 1 minus 8x inside the radical, and that would be minus 3. And down the bottom, I have x plus 1. X plus 1, but x goes to a negative 1. Okay, so you want to find you want to find these limits. Again, a direct substitution to see if you can get it. And if you directly substitute, that gives you 0. And directly substitute negative 1, that gives you 1 plus 8 radical 9. It would be 0, 0. Okay, so you can test it, you can show it. Or if you are sure about it, just go ahead. Go ahead with your method, if you don't mind. But I'm going to explain. So, and this is it. I just repeat it. Then I substitute. But again, you can ignore it or you can do it right at the beginning. So if I substitute negative 1 carefully, that gives you 1 minus 8, use parentheses, negative 1 outside, negative 3, and that is x plus 1. Okay, I'm sorry, I'm substituting. It's a negative 1, negative 1 plus 1. So the bottom one would be 0, the top one would be radical 1 plus 8, which is a 9. Radical 9 minus 3, so that's going to be 3 minus 3, 0, 0. Okay, 0, 0, question mark. Okay, so again, it's a indeterminate form. So what's the message here? Any suggestion? Of course, there is a common factor. What is that common factor?
X plus one.
X plus 1. Very good. You see x goes to -1. X plus. Remind yourself that x plus 1 is a common factor. Common factor. You already got it here. You want to create on the top. You see the top is not a polynomial. It's a radical expression. So you have to multiply the top and the bottom by the conjugate of the, okay, the top one. The conjugate would be the same radical, but with the plus. Okay, again, you can start this one right at the beginning. We don't mind. So that's it. This is how we do it. So I have the first one. Okay, the radical 1 minus 8x. So this is it. I'm going to multiply, just do it right away. I'm going to multiply by its conjugate. So the conjugate is going to be radical 1 minus 8x plus 3. Okay, the bottom one is x plus 1. I do the same thing to the bottom. Okay, so this is going to be what? This is going to be 1 minus 8x plus 3. Again, when we get the experience, we do it right at the beginning. Now, remember, you are not going to touch the bottom because you need x plus 1. On the top, that theorem that we talked about, the square of the first minus the second. So it's going to be the limit of, again, you can do it in short form. It's going to be a square of the first one, radical 1 minus 8x all squared, minus the square of a second one, 3 squared, or just do it right away. Multiply these two, remove the radical, 3 times 3, 9. But you are not going to do anything to the bottom. So the bottom one is as is. Stay on the top, simplify it, remove the radicals. So that give a limit of x goes to -1. The top, you remove the first radical, that give 1 minus 8x. And the second one, 3 squared, would be 9. Again, the bottom is unchanged. Okay, so that's going to be 1 minus 8x plus 3. Stay on the top. Remember, you need x plus 1. So you have to simplify the top so that you get that x plus 1. So we continue. You combine the like terms on the top. So what's the like terms that we have? We have a -8x, start with the x part. And you have 1 minus 9, which is going to be -8. That's the top. So the bottom one would be x plus 1 times the radical 1 minus 8x plus 3. Okay, you need a little bit more algebra here. What is that? You see, this is x plus 1. Remember, this is your common factor. You want to create x plus 1 on the top. What are you going to do in order to get x plus 1 on the top?
Factor out an 8.
That's it. Factor out a -8. So that's your extra job for this group of the problems. Okay. So factor out the -8. So that gives us x plus 1. You see, you must get your common factor. So that's why you need this factoring. So we have the radical 1 minus 8x plus 3. Now we get the common factor. Remember, limit, 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 limit. Now we can eliminate the common factor. Left over is going to be equal to the limit of x goes to -1 and the top. The top we get the -8. And the bottom one is 1 minus 8x plus 3. That's it. Now this is the time to substitute. You substitute x equal to -1. So that gives a -8 on the top. Okay, the square root of 1 minus 8 times a -1 again, plus 3. Carefully simplify it. At the top, you get the -8. Okay, we have a -8 here. And down the bottom, it's a -8 times, you know that you do the multiplication first. So that give 1 plus 8. I write it down so you know what's going on. Okay, plus 3. So that give you -8. The bottom one is a radical 9 plus 3. Radical 9 would be 3. So -8, 3 plus 3. So that give you -8/6. Okay, -8/6, but you have to simplify. You know that fractions must be given in its lowest term. So if you simplify by 2, so that gives -4/4. Final answer. So I repeat it again. So it's very important problem that you did. It's 1 minus 8x minus 3 over x plus 1 when x goes to -1 is simply -4/3. The final answer. In future, you realize that what you did, you find the slope of a tangent line to the graph of y equal to the radical 1 minus 8x. Or you did find the derivative of the y equal to the radical 1 minus 8x at x equal to -1. We have a shortcut for this one in future. We call it the chain rule formula, but not now. Okay, so that's a very important case. Pay attention to it and make sure you can do it. Okay, so basically the first part, you realize that there is a common factor, or just you see the radical expression on the top, multiply the top and the bottom by the conjugate. The conjugate, and you know that the common factor is x plus 1. You see x goes to -1, you move the -1 to the other side, make it to the +1. So we know that we are looking for the x plus 1. So we multiply the top and the bottom, okay, by the conjugate of the top. Patiently, okay. Then we are not going to do anything with the bottom because we need that x plus 1. So on the top is a special FOIL, square of the first minus the square of the second. Then you combine the like terms. You realize that you are looking for x plus 1. So you may need a factoring here. In this case, we need to pull out the -8. So we have a common factor, which is x plus 1 and x plus 1. Simplify it. We get the -8, substitute the -4/3, the final answer. Okay, so that's very important case of this 0, 0 case. Okay, any question? Now we have one more of this group. Again, this next one is very important in future. And that would create a formula in future. We call it the quotient rule for the derivative of the function. So, you know, it's going to be a bonus. So that if we get a little bit more examples or more details examples in this part, that will help us to understand it and be prepared for future. Okay, so that's number 6. Are you ready? Number 7, another surprise, another case. What is this number 7? This number 7 is going to be of this form. Remember, in a case 1 of these 0, 0, we get a polynomials on the top and the bottom. Case 2, we get a radical function on the top. In this case, we have something in algebra, we call it complex fractions. Complex fraction means fraction of fractions. You see, the common fraction is 2/3. 2/3 is common fraction. But if it's going to be 1 plus 2/3 divided by 5 minus 1/2, this is going to be complex fraction. So it's going to be this format. The limit of, again, historically very important problem, this one. And we give you one, your next quiz and the test one. X minus 1 divided by x plus 2 minus 2/5 on the top. Okay, and this is going to be x minus 3. You see, you want to do this one. Again, as usual, you directly substitute because, you know, it's a fraction, you know that it's the limit's going to be top, bottom. So you just substitute, you may get it, you know, especially the problem in your book. You know, there are some of them in your book that, you know, you substitute, get 1/2, 2/3. So just checking. So the checking is you can do it in the short form. Okay, so that they're not going to repeat it. So in the in the short form, this is the situation we have. If you substitute, if you put the 3 to check it, it's going to be 3 minus 1 divided by 3 plus 2. And this is going to be 2/5 on the top. And then the bottom would be 3 minus 3. On the top is going to be 3 minus 1 would be 2. So that give it 2. 3 plus 2 would be 5, 2/5, 2/5. And that would be 0, 0, 0. You see? So this is again is going to be indeterminate form. So what's the message for this one? There is a common factor. What is that common factor?
X minus 3.
X minus 3, excellent. X minus 3 is going to be common factor because X goes to 3. Okay, it would be helpful to know our target. So X minus 3 is a common, okay, it's going to be a common factor. So we have to find it and eliminate it, okay? You have to find the common factor and eliminate it. So what we are going to do for this one, you see, it's not a polynomial to factor it. It's not a rational function to use the conjugate. It's a complex function, complex fractions. We have to simplify the complex fractions. Simplification of complex fraction is you just do this subtraction here. You see, you find the common denominator. It's like a difference of two. How we're going to find the difference of two fractions. Okay, you find the common denominator and just you do the job. So we do the same thing over here. And as soon as you simplify it, that common factor would appear and then you'll be done. Okay, so there are different methods to do it, but this one is easy. So I just repeat it. Okay, so this is, or you can do it right at the beginning. You see, find the common denominator. So this is going to be the case, is a limit of, again, you have to keep the limits all the time. You see, I'm not going to do anything to the bottom because X minus 3 is your common factor. On the top, you find the common denominator. You know that the common denominator will be product of the factors. So it's going to be 5 times X plus 2. And on the top, you know that you are going to, you divide 5x plus 2, divide by x plus 2, the leftover is going to be 5, or just a cross multiply, you see, 5 times x minus 1 minus 2 times x plus 2. So I just find the common denominator. Any question? So the common denominator would be the product. And the top is just cross multiply, if you like. It's a 5 times, the shortcut is 5 times x minus 2 minus 2 times x plus 2. Remember, you are looking for the common factor. So continue on the top here, simplify it. So you keep going to get your common factor. So nothing to be done here. Nothing to be done here. Continue on the top, distribute differences. So if I distribute this one, I'll get 5x minus 5 minus 2x minus 2 times 2, 4. Some people, they miss this sign here. When you do the negative, you see you do it for both of them, not just for the first one. If you didn't get the common factor, probably you missed this one. Okay, so I distribute it. Now you combine the like terms, stay on the top. The limit of x goes to 3 again. So that's going to be x plus 3. So you're not going to do anything here. On the top, combine the like terms, 5x minus 2x, that give you 3x. And negative 5, negative 4 would be negative 9. Remember, you are looking for the common factor. Okay, your common factor would be x. I made a mistake here, that's a negative. Okay, the common factor is x minus 3. You have a 3x minus 9. So you have to That's going to be x goes to 3. This is going to be x minus 3. And this is going to be 5 times x plus 2. Now, what are we going to do to the top to get the x minus 3? You have 3x minus 9, but you want
Yeah,
x
that's
minus.
3.
That's it. Yes, factor out the 3. So that gives us x minus. You see, you will get our common factor. So you have to simplify it and just keep going. Then you get your common factor. You see, this is going to be a common factor. So the common factor out, you eliminate it. When you eliminate this one, the denominator would be 1. You eliminate this. So the leftover is going to be simply, so you end up with a fraction on the top. X goes to 3. And you get a 3 over 5 times x plus 2. So you have to simplify it as long as you know, so that you get that x minus 3 on the top. Now you substitute. So that would be 3, 5 times x is 3, 3 plus 2. So that gives us a 3 times 5 times 5, which is 3 over 25. The final, the final answer. Okay, so I repeat it. So the limit of x minus 1 over x plus 2 minus 2/5 over a, you don't have to, but I just repeat it. So my final answer is going to be 3 over 25. That's it. You did a very important results. Okay, in future, we can do this one in shortcut, but not now. This is the slope of a tangent line to the graph of y equal to the x minus 1 over x plus 2. Or is the derivative of this function at x equal to 3. In future, we have something we call it quotient rule. We use quotient rule to take this one, but not now. This is just the beginning, and that help you to learn these type of techniques. Okay, so this is I don't know why, but for some people it's going to be challenging one on the test, but we keep up the order that we have over here, especially this part. You see, this is just a subtraction of 2 fractions. Is a subtraction of 2 fractions. If you want to subtract 2 fractions, the way we do it, we need to have the same denominator. Okay, so it's a common denominator, which is the 5x plus 2. Then you see, you multiply the top by the missing part. Really, this x minus 1, the missing part is 5, so that's why we multiply by 5. And over here, the missing part is x plus 2. Or just cross multiply to get that. Okay, or whatever method you prefer from algebra. There is another method in algebra that they multiply the top and the bottom by 5 times x plus 2, but not a big deal really. So keep it in this form. The mistake that the people they do or make is this one. As soon as they put here, they try to simplify these two together. You can't do it. You can simplify factors. This is not factors. It's at the end. There is a negative here. Okay, so as soon as you put the top, you have to continue on the top. Continue on the top, combine the like terms, automatically you will get your common factor. Most of the time you have to factor out something. Sometimes you may have to factor out the negative 1. So these are going to be the challenge to get this one through. But it's a very important case for the finding the limits. Any question? So 3 very important cases, 0, 0 with the complex fractions. That's going to be the case. Okay. 0, 0 with the polynomial. 0, 0 with the radical expression. This is your radical expression. You get the conjugate. And the 0, 0 when we get the polynomials. So 1, 2, 3. Okay. This is going to be 3 cases that you have to take care of. And for this quiz, we give you all the 3. And for the test, we usually repeat it again on test 1. We need this type of ideas. As I told you, when we get to the next chapter, we already done. We already got all the information that we need. So that was number 7. Any question? What else? Okay, number 8. Number 8 is again an easy case, but it's important for us to know it. You see in calculus, anytime you see some expression involving the absolute value, that's a red flag. So we just give you this one, the limit involving the absolute value, and show you how we're going to handle it. So that would be our case 8. Okay, going to the 8. What is this case? Again, you have a similar problem in your assignment. Just check them, but more important than you get the practice quiz and the practice test. By the end of today, you should be able to do all those problems. So what's case 8? The case 8 is easy problem, but involving the absolute value. This is the case 8. So you have absolute value function, x minus absolute value of x minus 5. And this is going to be x minus 5. Okay, and they wanted to find x goes to, for example, 5 positive. Right, and the left limits that we talk about it. We want to know what's going to be this one or how we're going to handle it. You see, you can directly substitute. If you directly substitute, so that gives you 0, 0. Okay, so this means there is going to be a common factor. What's common factor for this one? When we get the 0, 0. Common factor. X minus 5. Yes, Cameron, you're right. X minus 5, you see, if you substitute 5, you get 0, 0. So x minus 5, it doesn't matter. This is a positive or negative on the top. Okay, so the common factor is x minus 5. So you have to find that common factor and eliminate it. But we already got it here. That's x minus 5, but this is absolute value of x minus 5. So you have to take care of that absolute value to be able to do it. You see, that's going to be the difference between these problems and the other ones. Okay, so basically, this is going to be the case that it's, you know, if you substitute, you get the 0, 0. You see, I just remind you again. You see, because the positive is just a direction, but the number is 5. So if you put the 5, so that give you absolute value of a 5 minus 5. You don't have to do this one. I just want to remind you, it's going to be 0, 0. Okay, so basically this means again, x minus 5 is a common factor. Okay, it's going to be a common factor to get this one done. But the situation are going to have the absolute value. Just remind you, just put the remark for you here. Remark. The remark is going to be, you know, we just recall that if you have something like, you know, we can call it the absolute value of u. You know that if u is a positive number, so you drop the absolute value. So if this is going to be the case when u is positive, if u is 0, so that would be 0. Okay, u equal to the 0. But if u is negative, you see the result of the absolute value must be positive all the time. Then we switch it into the negative u. Okay, so this is the definition of the absolute value. And you know that the absolute value of 7, for example, is 7. Absolute value of 0 is 0. But if you want to find the absolute value of a negative 8, it's going to be opposite of the negative 8. Opposite, negative 8, that give you 8. That's how we handle the absolute value. So if you are sure that the inside is positive, you drop the absolute value. If you know that the inside becomes a negative number, you use the opposite of the inside. Opposite of the inside. Opposite of the inside is a negative 8. The opposite would be negative 8. That give you 8 here. Okay, any question? Now getting back to this one. We want to know what is the nature, what is the sign of the inside when x goes to 5 positive. So what we are going to do is x goes to 5 positive. Do you remember what does it mean? X goes to 5 positive.
It means X is approaching 5 from the right.
Excellent. This is 5. So that would be the positive. That would be the negative. Okay. So when you are here, this means x is greater than 5 because it's in the direction. If you are here, this means x is less than 5 because you pick the number like 5.1, 5.3, 5.6, etc. But over here, you pick something like 4.9, 4.7, 4.8. So as you can see, when x goes to 5 positive, x is bigger than 5. When x is bigger than 5, this means x minus 5 is positive. If you are going to be here, this means x minus 5 is negative. Because when you are here, you pick 5.1, 5.2, 5.3. So the difference is always positive. But if you are here, you pick 4.9, 4.7. So it means the difference is negative. If the difference is positive, the absolute value of x minus 5 is going to be x minus 5 because it's positive. But if you are going to be here, the absolute value of negative 5, it is negative. It's opposite of the inside. Opposite means negative x minus 5. You see, this is the thing that you have to know it when you want to solve the absolute value problem. So when x goes to 5 positive, the inside of the absolute value that x minus 5 is positive. So you don't need the absolute value, drop it right away. If it's going to be 5 negative, so the situation would be different. So this is how we handle this graph, this limit. You don't need all these that I talk about it. So the limit of x minus 5, x 5, x goes to 5 positive. You see, it's equal to, remind yourself, that's x, just explanation. Remind yourself that x is bigger than 5. So the inside is positive, so the absolute value of x minus 5 is simply x minus 5. So it's going to be limit of x minus 5 over x minus 5. X goes to 5 positive. You see, this is the common factor that you've been looking for. You divide, you get a 1, 1. So it's going to be 1 over 1, which is equal to 1. So the limit is 1. So the limit of the absolute value of x minus 5, x minus 5, x goes to 5 positive is simply equal to 1. And you're done. Any question? So that would be important for us, the absolute value. There are a couple of places that we're going to use this in future. Just make sure you know it. Okay, so basically you have to check to see what is inside. Is it always positive or is it always negative? Since x goes to 5 positive means the x is, you can pick a number, 5.1, 5.3, 5.6, but all of them, the difference is a positive number. So you can drop the absolute value, x minus 5, and that give you the final answer. Any question? I have one for you. How about if you get 5 negative? How about the limit of absolute value of x minus 5, x minus 5, x goes to 5 negative this time?
It would be -1, the final answer.
Excellent. Yes, very good. Yeah, because x goes to 5 negative, you are here. You say x is less than 5. When x is less than 5, the difference is always negative. You see, the difference is always negative because you are going to be into the left there. So you get the -1 divided by 1. -1 over 1, then give you -1. Okay, so be careful to see which one is it. And you have all these categories in your assignments. So that's it, the limit of the absolute value of x minus 5 over x minus 5, x goes to 5 negative. So for your information, you just think about that x is less than 5 this time. So when it's less than 5, it's going to be limit of the top would be negative x minus 5. Opposite. You see, since the inside is always negative, you have to make it positive. So that's why I use the opposite, like the opposite of negative 8 here. Okay, and this is it. X goes to 5 negative. Again, you simplify it, that give a negative 1 over negative 1, which is a negative 1. Okay, so don't miss it. It's so the limit of x minus 5, x minus 5, x goes to 5 negative is a negative 1. Any question? So that would be helpful to know it. But there is one more case. What's that case for this one? Any suggestion? What's the other possibility that you can have for finding this limit? This is the one I did. I did x goes to 5 positive, and I did x goes to 5 negative. So what is the other possibility? Oh yes, very good, Cameron. The other possibility is what would happen if x goes to 5 only? You see, this is going to be the last possibilities. So how about the limit of the absolute value of x minus 5? X minus 5, x goes to 5 this time. You see, the first case and the second one was the right and the left limits, but this is the limit. Any suggestion for this one?
Indeterminate.
So what's the final case?
Limit does not exist.
0 and
yeah.
0.
Yeah, that's it. Does not exist. You see, if this is going to be given to you, when x goes to 5, remember, the only thing that you know is x is not equal to 5. X is not equal to the 5, but it can be. You see, that's the case now. This is 5. So the case that you'll be given is both of them at the same time. You see, we cannot handle both of them at the same time. But what we have to do is we have to break it in 2 parts, right and the left limits. So if it's going to be given to you on the test, this is the way you're going to do it. We say, oh, this is the, I can't do it as is, so I'm going to find the right and the left limits. You start with the limit of absolute value of x minus 5, x minus 5, x goes to 5 negative first. Remember, the 5 negative, we are to the left, so the top would be negative. So we say it's going to be limit of a negative x minus 5 over x minus 5. X goes to 5. You simplify that, give a negative 1, which is a negative 1. Okay, this is your left limits. And you repeat it again. You say, oh, on the other hand, the limit of the absolute value of x minus 5, x minus 5, x goes to 5 positive. If you are going to be in this direction, remember that would be x minus 5 over x minus 5, x goes to 5 positive. So in this case, you get 1 equal to the 1. Remember, the right and the left limit are not the same. So negative 1 is not equal to the positive 1. So this means the limit of the function, the limit of the absolute value of x minus 5 over x minus 5, when x goes to 5, does not exist. That will complete all the possibilities for the absolute value function. Okay, and there is one crucial place that we're going to use this one in this course only. But it's nice to know that anytime you want to deal with the absolute value, you have to remove it first. But when you want to remove it, you cannot remove it if it's going to be x goes to 5. Because you should be able to check whether you get a positive or negative numbers down there, okay, inside the absolute value. So the only way that you can get this positive or negative inside is if you do it one-sided. You see, if you break it in two parts, x goes to 5 negative, the top would be negative x minus 5. If it goes to 5 positive, the top would be x minus 5. But we get two different numbers. So this means the actual limit does not exist. So that would be very, very important case. And we usually give you one of them, of these three together, and you have it in your practice one. Okay, you don't need to give us any details. Like the last part that I did is okay for us. But you need those details to understand it, to get those numbers. Okay, any question? So that's the situation with this absolute value of function. But we did the right and the left limits, so that it will take us to give one more, then I'll give you a break. So that will take us to these type of problems in general. And again, another very famous problem, number 11. Number 11, remember the piecewise defined function? I give you one of these examples that the other day, just to remind you what I'm going to do. Remember this one? Find the right, left limits. We did it using the graph, but now we can do it with algebra. Again, this is a very important case. You get quite a lot of these type of problems in your book. Okay, so that would be our, which case is it? Case 11. I told you something like 16 problems. Okay, so we are getting to that. So what is going to be this case? It's a very popular case. And we give you one of these on your first quiz and the test. So one of the problems on the quiz is this one. Suppose we get a function. You give a piecewise defined function, f of x is equal to, okay, is equal to the 3x squared minus x plus 1. When x is less than -1, we partition the function, and the other one is 1 minus 8x when x is greater than or equal to the -1. It's a piecewise defined function, okay? The function is partitioned, and it's partitioned at -1. So they usually ask you 4 questions, and these are going to be the questions that you have to answer. Would like you to find each of the following. Each of the following. So what's going to be the case? In the case 1, they ask for the, you know that if you want to find the limit of the function around -1, you can't do it right away. You have to do it one-sided. So the first part, they ask what is the limit of f of x, m of x when x goes to -1 and negative. Remember, this -1 is just the number. But this -1 on the top means the left limit, okay? Limit left and the right. So they ask for the left limit at -1. Case 2, they ask for the limit of f of x. X goes to -1 positive. So this means the right limits. Case 3, they ask for the limit of f of x when x goes to -1. Just find the limits. And the case 4, what is the value of the function f of -1? Okay, 1, 2, 3, 4. The exact value that we are asking for. Okay, for each case, you have to check to see which part of the function can you use. Then you break the function, and then the direct substitution give you your final answer. Okay, are you ready? Solution. I explained the first one, then you do it in short form, but I like to explain it. So this is the way we're going to do the first part. You want to find the limit of f of x when x goes to -1, negative. You see, you have two portions. You are going to use only one of them. You have to decide which one are going to use for this. You bring it down, direct substitution, give it final answer. Now, x goes to -1, negative. What does it mean, this one? Any suggestion?
X is approaching -1 from the left.
From the left. So since it's from the left, I just explained this one, we get a little bit. So this means x is less than -1 from the left. So you have to use this part for your function, that's it. So x is less than -1. I just remind you that your f of x is what? Your f of x is 3x squared minus x plus 1. That's it. So you want to find the limit of the 3x squared minus x plus 1 when x goes to -1, negative. From now on is a direct substitution. You see, we substitute -1 because that was just the direction. So that gives you 3 times -1 squared minus -1 plus 1. Okay, substitute. -1 squared is a positive 1. So that gives you a 3. Okay, so it's going to be 3 plus 1 plus 1. So the result is 5. So the left limit, okay, limit of f of x, x goes to -1, negative, is equal to the 5. And you're done. Any question?
Yeah, I have a question.
Yes.
So you just did direct substitution, which is fine. Is that the case then would that be the case then for number 2? Because I
Yeah.
thought like coming from the left, you'd want to pick numbers less approaching 1, -1 from the left. I thought you'd want to pick numbers less than -1.
No. You see, this negative will just give you the fact that which function are going to use. Okay, which
Okay.
part of the function. So you are going to be in the first part. Okay, so this is your function. This is your function. That theorem that we talk about it, remember the polynomial type for direct substitution?
Yeah.
That theorem is true for right or left limit as well. So that's the left
Okay.
limits. Okay, if you substitute those numbers you talk about it, you get the same answer.
Yeah,
But
that's the question. That's what I was wondering.
yeah. But computing theorem is true for all one-sided limits. So we can change all the limits to the x goes to a positive, a negative all the time. Okay. So the theorem is, is true for each limits.
So then would that mean that
Mhm.
the answer, like there's always going to be a limit? The limit would always be the same then, because if you're just plugging in the number by itself.
Yeah, if it's
No.
polynomial.
Okay.
You see, so far we're just checking polynomial functions. That's why. But in a minute or today, you're going to see some other functions. You see, if you get the trigonometric function, sine, cosines, they are not polynomial functions. So you need some other tools. And so that's
then-
why we are lucky that we get this.
And then another question, you keep doing the double underline under the so it
Yeah.
says x less does the double mean anything? Like,
No,
is it
no,
an abbreviation
no, it's just
something?
equality sign.
Okay.
Yeah, I just want to explain it. I'm not going to do it for the second part.
Okay.
This is the one that you talk to yourself, for example. You say, oh, I want to find the limit of f of x, x goes to -1, negative. So you say, oh, this means x is less than -1. When x is less than -1, I have to use this function. You see, this is the psychology of the concept, if you like. But I just want to explain it. Okay, any question? So now it's clear to do what you do to the second part. In the second part, now we can write on the short form because we explained everything we need. Now be careful, sometimes they switch it. It's not the case that always they ask for x goes to -1, negative first. They may go with the positive first, so read it. Okay, so we want to find the second one. Now we get the second one quickly. X goes to 1 positive. So I can do this one quickly. I just remind you something that x goes to 1 positive. What does it mean, this one?
It should be -1 positive.
Oh, I'm sorry. Yes, thank you. -1 positive. Oh, -1 positive. X goes to -1 positive. Thank you. You see, in this case, you know that x is bigger than -1. When x is bigger than -1, this is the function that we're going to use. Okay, the second part. So the function to be used is the second part. So you bring the function and you substitute. It's a limit of 1 minus 8x when x goes to -1. As soon as you bring the function, the theorem, it doesn't matter whether it's a 1 positive, 1 negative, the number is -1. So you substitute the -1 again. 1 minus 8, -1. Okay, so that gives you 1 plus 8, which is the radical 9, and the radical 9 is 3. So the right limit, okay, so the right limit is equal to the 3. Any question? So, you know, I put it over here just to explain it. But check which portion. You know that you cannot use both parts because that's a function, just using one part. So that gives you the direction. -1 positive means x is greater than -1. So the function to be used is the second part. Now to answer the second, to the third part, since it's a piecewise defined function, you check the right and the left limits, you see. From the left, we get the 5. From the right, we get the 3. Since the right and the left limits are not the same, so this means the limit of the function at -1 does not exist. And that was, remember, in the computing theorem, that was part 7 of that function. See this theorem? If the right and the left limit are the same, it's the same number for the limit. So this means if the right and the left limits are not the same, so this limit does not exist. So there are two possibilities for these problems. The possibility that you get both of them the same. So that same number would be the limit of the function. And the possibility that they are different. So when they are different, you can say 5 not equal to 3, but this is the first one. I'm going to explain it. So we just explain that the limit of f of x goes to -1 is not -1 negative. Is not equal to the limit of f of x goes to -1 positive. So that would implies that the limit of f of x goes to -1 does not exist. Okay, this is the way we accept it, or simply, or this is the way you can do it on the test. We say simply 3 is not equal to the 5. So this means that the limit of f of x goes to -1 does not exist. If they happen to be the same, you say, oh, 5 is equal to 5, so the limit is 5. Okay, so this is the way we are going to find that limit. It's true all the time, you know, even if you directly, you want to, in calculus, in general, in calculus, if you want to do anything to the function, to the piecewise defined function at the partition point, this is partition point -1. You say you have to do it one-sided. You have to check the right and the left limits. We are going to have the other concepts. Continuity differentiability is going to be the same thing. Okay, any question? So that is the part 3. We have one more part to go. What is f of -1? This is the exact value. You see, that was the estimate. We estimated -1, we didn't get anything. Can you find f of -1? So that's algebra. You go and check to see where can you put x equal to 1. You cannot do it here because there is no equality sign here. But there is equality sign here. So in order to find f of -1, you are going to use the second part. Okay, there is a possibility that if this equality was missing, so in that case, you cannot find it. In that case, we say f of -1 is undefined. Okay, does not exist or undefined. So there are two other, two possibilities for this part of the question. But for this part, we have the answer for it. So f of -1, we can find it. So that's a part 4. Part 4, you want to find f of -1. Do you have the x equal to -1? Yes, we have it from the second part. So we have the substitute here is going to be 1 minus 8 times a -1. We already done this one. That give us 1 plus 8 radical 9, and the radical 9 is equal to 3. So f of -1 is equal to 3. And that's an interesting case. You see, you can find the exact value of the function, but you cannot find the limit of the function. So we cannot estimate it around the -1 when it's getting closer and closer to the -1 from the left and the right, because it's a partition. This because it's a two partitions when you graph it to get this one. Okay, so it's very important problem because we can have two more other cases. So that's why they like it. And the type of function that used in science, they are all piecewise defined function. That's why this example is very important. Much less in calculus 1. It's a good example for calculus 1. Any concept that we are going to study, this is going to be a challenging one for us. And if you take calculus 3 again, this would be so important, this argument that I did over here, and I've used it all the time. So that's a famous case of number 11. Any question? So study this one carefully. You will see it in, this is your first question on the quiz, NUM, and the first question on the test 1 that we're going to use it. So I'll give you a break. So we have 5 more cases to talk about it, to finish it. There is a converse to this one. We come back and talk about it. And then for the other 2, we need a little bit more formulas to do it. Okay, so it's a 9:25. Let's see you, about the 10 minutes, 12 minutes, 10 minutes. So see you later. Okay, any question? We're going to continue. So the last one that we did, this is a piecewise defined function. Okay, so whatever we want to do with the piecewise defined function in calculus, we have to do it one-sided. Okay, you have to find the right, the left limits. And we just compare them together. Each time you want to get the one-sided limit, you have to decide which part of the function can you use. Okay, you cannot do both of them at the same time. So it depends on the direction that's going to be given to you. So read it carefully. X goes to -1, negative. That negative on the top is just a direction. But basically the limit is going to be taken at the -1. So bring the proper part of the function and just substitute, because these are all direct substitution, because we're dealing with either, polynomial type functions all the time. So if the right and the left limit are the same, so you get the actual limit for the function, part 3. And if you want to find the exact value, you look to see where equality sign is given to. Now, there is going to be a converse to this problem that they usually offer. And that would be related to this right and the left limits, whether they are going to be equal to each other or not. So let me just give you this one. You have a couple of them in your book again, at least 2 in your book. And so that would be our problem number 12. Again, you will see it in your quiz 1. What is 12? It's very similar to the 11, but let's see. So suppose you have this function. Again, a piecewise defined function would be given to you. In this case, f of x equal to, okay, f of x equal to for example, you have a 5mx. There's going to be another parameter involved, m, 5mx plus 1. This is going to be the case when x is less than 1. And this is going to be 3x squared. 3x squared minus 5mx. 5mx plus 2 when x is greater than 1. Okay, so it's again a piecewise defined function in partition at 1. So if you want to talk about the limit at 1, then you have to consider the right and the left limits. So when we find it, they may be equal to each other or they may be not. But in this problem, they are going to ask you to find, you see, let's write it down, find the value. So find the value of the constant. Find the value of the constant m, so that, okay, so that these the 2 limits, one-sided limit of f of x goes to 1 negative, is going to be equal to the limit of f of x goes to 1 positive. You see, that's a related problem to that one. Okay, because with the examples that I gave you, you may find the right and the left limit. They may be equal to each other or they may not. So what you would like to do is you would like to guarantee that they are going to be equal to each other. But to guarantee it, you have to find this unknown m, if you like. You see, in order to find the unknown m, you need an equation. You have to find an equation, solve that equation for m, and you get your final answer. So that equation is this one that's given to you. So in order to find the m, so what you have to do is you are going to find you see, you have to find the left limits. You find the right limits. Of course, both of them would be in terms of the m. You let them to be equal to each other. That will provide an equation for you. You solve that equation for m and then you're done. Okay, so this is another type of related problem. It's a techniques that you have to know it, okay? From time to time in various places, we use these type of ideas in calculus. Okay, so let's do it. So we're going to find this. What's the limit of f of x? X goes to 1 negative. Again, as we talk about it, x goes to 1 negative, remind yourself that this means x is less than 1. So the function to be used is the first part. Okay, this is it. So you have to find the limit of the 5mx plus 1. Okay, x goes to 1 negative. As soon as you bring the function, the next is going to be substitution. You substitute 1 for x, of course. It's a 5m times 1 plus 1. So in that case, you get a 5m plus 1. Okay, so it's going to be limit of the function in terms of the m. So that's the left side of the inequality that you have. Okay, now find the right one. Repeat it again. Limit of f of x, x goes to 1 positive. Again, remind yourself. Again, you don't have to write it down. I just remind you. X goes to 1 positive means from the right. So from the right means x is greater than 1 this time. So the function to be used is the second part. So it's going to be limit of 3x squared minus 5mx plus 2 when x goes to 1 positive. Directly substitute 1 for x. 3 times 1 is squared. It's going to be 5 times m times 1 plus 2. 1 would be 1, so it's going to be 3 plus 5m. Okay, so that give you, I made a mistake here. There was a negative sign I missed. Sorry, that's a negative, yes. Okay, so it's going to be negative 5m and the plus 2. Okay, 2 and 3 would be 5, so that give me negative 5m plus 5. Okay, so I find the left-hand side and the right-hand side of the inequality that I have. Okay, so according to the information, you want to find the m so that they are equal to each other. So what you're going to do is you are going to let them to be equal to each other. Okay, let them to be equal to each other. You have the 5m plus 1 for the first part. And you have the negative 5m plus 5 from the second part. You see? Now you solve for m because this is the unknown that you are interested in. Solve for m. So you have to form that equation first. So for m, you know that you just, what you're going to get. It's going to be 5m plus 5m and the 5 minus 1. Okay, 5 and 5 would be 10. We get the 10m equal to 4. So m would be equal to the 410. You simplify it, m would be 2/5. You see, if you go back and you don't have to, if you go back and put m equal to the 2/5, and then if you find the right and the left limit at 1, both of them are going to happen to be equal to the same, and then you're done. Okay, so this is a kind of converse problem to the problem number 11. Any question? So sometimes they modify this condition. You will see it in your practice quiz number 1. Sometimes instead of giving you the right and the left limit equal to each other, they simply say the limit of f of x, x goes to 1 does exist. It's the same thing. You have to conclude yourself that the right and the left limits are the same, and you get the answer. Okay, any question? So don't miss it. I've given this problem several times on the test. Technically, some people, they missed it because of their writing. So I'm going to write what most of the people they write. They are not going to get any points for this problem, or they may get just 50%. And I ask you what is wrong with this solution. Okay, so this is the way some people they do it on the test. So that would be a wrong solution if you like. Okay, so let's see what they do. The way they are going to do it on the test, they begin by letting the first part and the second part to be equal to each other. So they write, so this is a question mark. What's wrong with this solution? They write the 5mx plus 1 is equal to the 3x squared minus 5mx plus 2. Then they substitute x equal to 1. They put x equal to 1 on both sides, so that gives us a 5m plus 1. And that would be 3 minus 5m plus 2, and then they continue. It's a 5m plus 1, negative 5m plus 6, as I got it over here. Okay, then they continue. It's a 5m plus 5m. And over there we have, I'm sorry, that's 5. Okay, so they have the same thing, 5 minus 1, so that gives you 10m equal to the 4. So m would be 410, and m would be 2/5. They write this one, but they won't get a full credit for this one. It just gets 1 out of 4. What's wrong with this solution? Of course, the answers are the same. Any suggestion?
Is it because you have to express the limit as x approaches 1 to prove that x is not equal to 1?
That's it, almost. The thing is, you see, where is the limit? You see, in this solution, where did you use the limit? You see, look at the condition that's given to you. They ask you to find the m, find the value of the m, so that the limits are the same. So the way we got it over here, we just set the function to be equal to each other. No, the functions are not equal to each other. The limits are equal to each other. So this is just the first step is wrong. You see, this is wrong, because you didn't use any limit. So you have to put this, you see the way I did it? I just find the limits first, 5m plus 1, the limit of the second one. Okay, the right and the left limits. Then I set the limits to be equal to each other. But in this solution, there is no limits. Where did you use the limits? Okay, so you better not use this one. I've seen it in this one several times. Many people, they do it. But as soon as you put it, I put the question mark for you and I ask you where is the limit. So find the limits first, then let the limits to be equal to each other, nicely get the result. And that would be easy problem and easy points not to miss. Okay, any question? You have 2 problems in your book in this category, but I put more on that practice one, and you have on the practice quiz and your test 1 as well, or the practice test. So check both of them, you will see it. It's a very popular method that later on we can use it for continuity and differentiability. That's why we need it. Okay, any question? So I almost give you everything you need to understand it, but you see whatever we need so far, they were all nice. They were all polynomial types. So as soon as we want to find the limit, we substitute, we get it, because these were all direct substitutions. There are a couple of others, tricky one, that you may not get polynomials and the function may be different. And so the one that we can talk about it at this level of the course is very famous limits. It's a trigonometric function. This limit is very popular in calculus, okay? So we have to get this one right away. So that would be example number 13. And number 13, I'm going to show you a couple of important limit that does not exist, but it's not the type that you can use these polynomial types, okay? So this is number 13. Number 13 You wanted to show these limits does not exist. Okay, number 13 is going to be show that the limit does not exist. Okay, does not exist. That is going to be the case. So the first part is we want to show that the limit of the sine of 1 over x goes to 0. This does not exist. And the second one is the same. Cosine of 1 over x goes to 0. Both of them does not exist. Okay, so these are going to be does not exist. They use quite a lot in calculus in different places, all through the calculus 1, 2, 3. So you have to know them. Okay, let's see how we're going to do it. Limit of the sine of 1 over x goes to 0. You see, when x goes to 0, you know that you cannot use the direct substitution for this one. It's not a polynomial types, and besides, when x goes to 0, you know that 1 over 0 is undivided. You can say that 1 over 0 can be infinity, then you have to check to see if the sign of infinity does exist. Okay, so how are we going to prove it? In order to prove it, you have to just show us there's no direct or short solution to this one. You have to go back and just do it as we did at the beginning. Remember some tables? So you have to pick some numbers which getting closer and closer to the 0. And show that if you pick those numbers, then this sine of 1 over x, we cannot round up the values. Okay, round up the values to get. But you can get help first to see what is going on for this one. Okay, so the solution is going to be, just do the first part. The first part. You still look at, if you use your calculator or graphing calculator, you can find the graph of, see, just consider, it's a very unique problem. So you are not going to see it on the test, but you have to understand it because there is going to be, the next problem would be related to this one. You see, consider the graph of y equal to sine of 1 over x. You need calculator, okay, to do it. So if you graph it just using your calculator, those TIs that you have, you see, you know that the sine function, the range of the sine is between 1 and -1. So the biggest value that this function can have is going to be a +1. And the smallest values that can have is going to be a -1. You see, if you graph it, this function, when we get around the 0, this is going to be a kind of, you know, the function is coming from somewhere here. Okay, and it's going to be nicely going up and down. Okay, but as soon as we get to the closer and closer to the 0, the behavior of the function is going to be this type, if you like. Okay. So around the 0, you see this is going to be the 0. Remember, when you want to find the limit of this function, you have to check, you have the 0 here, you see you have the 0 here. This is going to be the 0. So you check around this part to see if you can fix the value of your function. You see, when x is getting closer and closer to 0, the value of the function may be up, which is 1, or at the same time can be down, which is a -1. So these up and down are just such close to each other. If you graph it with your graphing calculator, you see quite a lot of up, down, up, down, up, down, up, down. So this means when we get close to the 0, you may get a +1 or you may get -1, +1, -1, +1, -1, +1, -1. So you won't be able to fix it. You won't be able to say that when x goes to 0, the value of this function would be eventually a +1 or a -1. So that will give us the idea that the limit of this function does not exist. Okay, so this is one way to prove it, but of course it's not convincing. Any questions so far? So as you can see, around the zero, you shouldn't, you cannot fix it. If you say the limit is 1, because you get quite a lot on the top, but at the same time, you get down, up, down, up, down, up, down, up, 1, -1, 1, -1, 1, -1. So there are infinitely many values that give you a +1, and at the same time, infinitely many values that give you -1. So you wouldn't be able to do it in that case. Okay, so this one way to do it, to remember it. But if you are going to be a math major in future, they are not going to accept this solution. So, oh, you say there are infinite numbers, you get possible -1, give us some of them. So that's why I want to show you that if you are going to be a serious, how we're going to prove it. So what I'm going to do, I'm going to give you these numbers. I'm going to pick the values for the x that give me +1 all the time. And I pick some numbers will give you -1, -1. So look at this. So let's see how I'm going to do it. Can you give me an angle whose sine is 1? Do you remember? Sine of what is equal to 1? Do you remember?
Would that be pi/2?
Excellent. Pi/2. Pi/2 is 1. Yes, very good. So what I'm going to do, I'm going to pick the numbers which are going to be close to the 0, so that I will arrive at this, because I want to get the 1 here. Okay, so this is the way I'm going to do it. So this is it. Note that. It's, if you want to be serious, this is the way you're going to do it if you're going to be a math major in future. Okay, note that if x is equal to, okay, I want to get the pi/2. This is 1/x. So I have to switch it because you have to use the reciprocal here. So what I'm going to do, I'm going to get this one to be 1/. Okay, I get the 1/. This is going to be the pi/2. So then when they switch it, the reciprocal, so that give you that pi/2 that I have. So we want these numbers to be very close to the 0. If you want to make this one to be close to the 0, you must take this denominator to be, okay, very big. So what we do is, this is it. I want lots of numbers. This is the pi/2. I put the 2n pi plus pi/2. So that's a 2n pi. 2n pi plus pi/2. Why I picked 2n pi? You know that the period of the sine function is going to be 2 pi. So that will help me to get lots of numbers. So I'm going to pick the x to be 1/2n pi plus pi/2. Okay. And this is going to be true when n is equal to the, okay, n is equal to the 0, anything you like. 1, 2, 3, 4, etc. Okay, so I'm here now. If I give you many points now, many points. Now, if this n is going to be a very big number, the numerator would be very big, very large. So the fraction would be very small. So this means if n is going to be large, if n is very large, okay, then x would be very small. X goes to 0. So x goes to 0 as n goes to infinity, if you like. Okay, so I give you lots of numbers. I give you lots of numbers that going to the 0. Okay, going to the 0. So I'm going to be around the 0. So what's going to be the value of the function now? What's going to be the sine of 1/x? Sine of 1/x. Okay, if you substitute, what's going to be the result? It's going to be the sine of 1/2n pi plus pi/2. So if you use the reciprocal, that give you the sine of 2n pi plus pi/2. And you know that it's a periodic function, so it's going to be the same as the sine of the pi half, and the sine of the pi half is 1. That's it. I give you lots of numbers, you see, lots of numbers that are going to be around the 0, but the value of the function is 1. So you may say that, you may conclude that the limit of the sine of 1 over x when x goes to 0 is equal to 1. Any question? So it's a little bit of proving of these type of ideas in mathematics, the way we do it. Okay, so what I did, I picked many numbers. You know, you can draw a table to get these, but I give you quite a lot. I give you quite a lot, and because of the sine of the pi half is 1 and the function is periodic. So since you want to x to be getting to the 0, so I just use this simple code to get to 0. So some people, they may be convinced. They say, oh, so what else do you want? You have many numbers and you prove that the limit is 1. You say, oh, bet. So what I'm going to do for you is, I'm going to do the similar one, but I would like to get the sign to be equal to the negative 1. You know that the sign of the negative pi half is equal to negative 1. So I'm going to pick the x to be, you see, I pick the x to be equal to the 1 over 2n pi minus pi half. Okay, it's the same thing. If it's going to be the case, then again, x goes to 0. As n goes to infinity, the numbers is quite a lot. And now the sign of the 1 over x. The same thing that we did over there. So that gives you the sign of 2n pi. 2n pi minus pi half. Sine is a periodic function, so that gives you the sign of the negative pi half, which is a negative 1. So I got many numbers, lots of numbers. X goes to 0 and the sign is negative 1. So the conclusion is going to be the limit of the sign of 1 over x when x goes to 0 must be equal to negative 1. So for many numbers I get a 1, for many numbers I get the negative 1. And that's exactly what will happen here, you see. Up, down, up, down, up, down, up, down, up, down, up, down. So, but 1 is not equal to negative 1. So this means the limit of the function does not exist. See, 1 is not equal to negative 1. So the conclusion is that the limit of the sine of 1 over x when x goes to 0 does not exist. It's a very famous problem in calculus. And so I proved it for you. We are not going to ask you to prove, but you better, you know, even if you have your calculator, just graph it, make sure you understand it, and make sure you remember it, that the sine of 1 over x does not exist. Similarly, the cosine of 1 over x is the same thing. It's the 1 over x, it can be 1 over x squared, x to the 5th, f to the 6th, or all of them. This type of limit does not exist in calculus. So that's a very particular problem. It's different from whatever else you did have or you are going to have in this course. Okay, any question? So, you know, if you love, you know, a little bit more getting involved in your mathematical expression, and that's very nice. This is the way we do it in future. You see, the calculus is a foundation of a branch of mathematics that we call it mathematical analysis. And that's the case that you prove everything. All the steps got to be proved. And this is a famous one that we're going to have. But that would form a collection of, okay, a collection of so-called counterexamples in calculus. So you have to know it. So we are going to be convinced with the graph. They don't usually explain this part for you that I did, but this is just for your information. Okay, any question? So it's not the case that all the cases are going to be polynomials. Polynomials are nice, those direct substitution. But if you want something unusual, this is one of them. Now, We have one more problem to take care of, and in order to take care of, we're going to modify this one a little bit. But in order to do it, we need another theorem to talk about it. So we talk about that theorem, and then we bring the last our example. And I promise you, then I will get to that number 15 or 16 problems that I promised you for this case. Okay, any question? So remember this one for future. Sine of 1 over x does not exist. It's the same for the cosine. And you can use your calculator to graph it. But in order to get to the last example of this section, we need something that we need a new theorem. What is this new theorem? It says sometimes you may get some inequalities and you want to use the notion of the limits. In order to do it, we have a famous theorem that we call it a squeeze theorem. So what is going to be? It's used mostly for the trigonometric function and especially the one that we talk about. So you have to know this one by name. It's very easy theorem, very important one. And the question that you will get from this part is very easy question. So what's going to be a squeeze theorem? We call it a squeeze theorem or sandwich theorem. So in short, anytime you want to use it, they say SQ, we accept it because we're going to refer to this one quite a lot. So what's going to be a squeeze theorem? A squeeze theorem is this case that you are going to have three functions. One of them is a squeeze between two others. Let me just graph it, the situation that we're going to have. The result is obvious, okay, but we have to design it. This is the case for the squeeze. So look at this one. You have going to three functions. Let me graph it, then you do it. Okay, this is going to be our first function. Okay, this first function, I call it y equal to the f of x. Okay, and there is going to be a point that we are going to consider. Okay, this is our first function. We have another one. So this is going to be another function. This is going to be y equal to the g of x. As you can see, the f function is above the g function. Okay, and there is going to be a point close here. Okay, so this is going to be a point. We call it the point A, if you like. Okay, and the situation is going to be so there is going to be another function we squeeze in between. So this is going to be the next function. It's going to be a squeeze between these two. Okay. So this is the one we call it h function. H of x. Okay, so we have three functions. So let me write down the theorem. So suppose we have three functions. Suppose f, and g, and h are given function. Given functions with these conditions such that okay, h is a squeeze between f and g. You have this inequality. You see the first condition is inequality. So h of x is going to be below the f, is less than or equal to the f of x. That's going to be above the g. We call it the inequality part. Okay, this is going to be true. It's going to be no for all x, if you like. All x. This is going to be the case, you know, near a number a. Okay, that's going to be the case. Now, the second condition is, you see, look at this one. If the limit of the bottom function, you see, limit of the, or the top one, limit of f of x, the top, when x goes to a, is equal to the limit of the bottom one, g of x. So the second condition is that, so such that, so the second condition is that the limit of the g function when x goes to a is the same as the limit of the bottom function or the top function. Let's say is equal to the L. Okay, as you can see in this is going to be the case for this one. So they are very close to each other at the point A. So if the, you know that it's clear that if the limit of the bottom one and the limit of the top one when x goes to A is going to be equal to the A, so what's going to be the conclusion? The conclusion is the limit of the middle one, the squeeze one. So if this is going to be the case, then the limit of the h of x when x goes to A is also equal to the L. This is the one that we call it a squeeze theorem. You see the L is somewhere, okay, somewhere here if you like. That is going to be the L. Okay. So this is used when you have this inequality, you need the equality. So this means if you have inequality and if you take the limit of the function to the right and the limit of the function to the left, all of them happen to be the same. So it's going to be the same for the middle one. And it's clear really. You see, if you estimate the value of the function at the right, that give you 5, and on left that give you 5. So h is between 5, 5. So this means the limit of the h is also equal to the 5. So that's one we call it a squeeze theorem. Okay, any question? So how are we going to use it? We're going to use it when the situation is arise, when you see, when you have this inequality over here. So sometimes inequality would be given to you, and sometimes you have to find it yourself. We are interested in a case that we have to find it, and that would be related to the, that trigonometric function that I talk about it for you. So I give you 2 examples to finish it. Okay, so that gives us example. If you like, this is example number 14 that we did have. The case 1, this is the case in your book, but I'm interested in the second case. You see, suppose you have a function f is f or h, let's say h. Suppose h is, this is h, is a function such that you don't have any formula for the h, but we have inequality such that h of x is going to be less than or equal to the x squared plus 2x plus 1, and it's greater than or equal to 2x plus 1. This is true for all x. Okay, you don't have the function, but you have this inequality. So we would like you to evaluate limit of h of x, okay, limit of h of x when x goes to 0. You see, this is one type of application that we had. You see, you don't have the function, but you have the inequality. So you can use the squeeze theorem. So we're going to do it. You find the limit of the function to the right when x goes to 0. What is this limit? You see, you substitute because the polynomial, the limit would be 1. You find the limit of the function to the left, 2x plus 1. When x goes to 0, you substitute, you get the 1. 1, 1. According to the squeeze theorem, the limit of the middle one is also equal to 1, and you're done. You see, this is the way we do the solution. You have to nicely explain it. So that's it. Find the limit of the function to the right and the left, limit of the 2x plus 1, x goes to 0, direct substitution, 2 times 0 plus 1. 0 plus 1 equal to 1. That's a function to the left. So do the same thing to the other side, limit of x squared plus 2x plus 1. When x goes to 0, again, that would be 0, 0, 1. So we get a 1, 1. So we can say that by a squeeze theorem. Okay, a squeeze theorem. That's a short. The limit of h of x when x goes to 0 is also 1, and then you're done. You see, we didn't have the function. We didn't have the function, but we can find the limit of the function because we have the information around the 0 here. This type of inequality was used by Fermat for the first time. He didn't have the notion of the limits, so he estimated all the values, and he estimated by inequalities only. And this is the way you write it down. Remember, you have to break it down. Limit of the function to the is not a left and right limit. Depends whatever limit you want. If x goes to 0 positive, you focus on the 0 positive. X goes 0 negative, you focus on that one. So it's a limit of the function to the right and the function to the left. If you get two different numbers, you cannot use this theorem. Okay, you can use this theorem only if their limits are going to be the same. Any question? That takes us to the last one. And the reason that we introduced the squeeze theorem is these famous limits. And that's the last limits that we need to know. This limit in calculus, you will see it all over the places. From time to time, in calculus 1, 2, 3, there are different methods to do it. I know 5 different methods, but you are going to use only this method in calculus 1. So that would be our number. So if you can consider that was a 13, 14, that's a 15, I told you. So I'm going to call it a example. There are a group of problems related to this one. We want to find this limit. Okay, find the limit. This limit can comes with the sine or the cosine, and let's do one of them. And you have a couple of them in your practice one. You get one question on the squeeze theorem on the test, on the quiz. One of those 6 questions would be related to the squeeze theorem. That's it. You see this one? You want to find the limit of x squared, sine of 1 over x, x goes to 0. That's how we're going to do it. Now, let's see what's going to be the common mistakes first. Some people, this is the way they do it. They say, oh, let me write it down. Wrong solution. They say it's a product of 2 functions. You see? They say it's a product of 2 functions, so it's going to be limit of the first one times it by the limit of the second one. See? Then they say the limit of the, what's the limit of x squared, x goes to 0? Any suggestion? First one? Limit of x squared, x goes to 0?
0.
It's a polynomial, you just substitute. So if substitute 0, that gives you 0. So the limit of the first one is 0. Since the limit of this first one is 0, they say, I don't care about the rest. So they say that the limit must be equal to the 0. So what's wrong with this one, this solution? The answer is correct, the limit is 0. Any suggestion?
You
I mean,
can't
the first
break.
part is right. Yes, it's a product. So it's going to be limit of the first function times the limit of the second function.
You have
But
to
the
add
limit
them.
of the first function is 0, so I'm not going to continue. So the limit must be 0. Any suggestion? What do you know about the second one? What's the limit of sine of 1 over x? X goes to 0.
It's one.
That's why I give you
Does
this
not
one first.
exist.
Look at this one.
Oh, because that one
Now, the
doesn't
limit of
exist.
Sine
One.
of 1 over x.
Or- oh,
X
no,
goes
it
to
is one.
0 does not exist. Okay, so you cannot say that I don't care about the second one. Yes, if the second one was a number, you can say that the number times 0 would be 0. But your difficulty is that limit of the sine of 1 over x, okay, x goes to 0, does not exist. So you cannot say that the 0 times does not exist is equal to the 0, you see? This is not going to be the case. So with this reason, this solution is wrong. Any question? The people, they do it on the test. Okay, so that's why I gave you this one first. So the only method that you're going to use to do it is a squeeze theorem. That's the best example for the squeeze theorem. Okay, so apply the squeeze theorem. In your book, they give you the hint, but we are not going to give you. Apply the squeeze theorem. Remember, to apply the squeeze theorem, you need inequality. You have to, squeeze this one into the two different functions. So in order to do it, we start with the sign. That's why they give you either the sine or the cosine. You know that the sine of whatever, it's always between 1 and -1. The range of the sine is true for the, if they give you sine of 1 over x squared, it's the same thing. Sine of 1 over x cubed is the same thing. Somebody may say, oh, x cannot be 0. Yes, cannot be 0 because x is not 0. So we say x is not 0. Okay, then you create what you want. What you want? X squared times it by x squared times by x squared multiply whatever you need. So what are you going to do when you get it, that give you negative x squared sine of 1 over x squared. You see, you squeeze your function. You squeeze your function between two other functions. Now we can apply the squeeze to, you find the limit of this part. Negative x squared, x goes to 0. You know that this is 0. You find the limit of this part. X squared, x goes to 0, that gives you 0. 0, 0. By a squeeze theorem. A squeeze theorem, remember, the limit of the middle one is also equal to the 0. And you are done. The best proof, or the shortest proof of these famous problems. We can do it in calculus too, use some other methods to do it. It's a very popular one. They may give you x to the 5th, x to the, it doesn't matter. But most of the people, they made a mess on the test for writing down this one. You see, the order of the proof is important. Sine is between -1 or cosine. Then you multiply it. Some people, they start with the x squared sine over x. They say it's between -1 and 1. It's not. Sine or cosine is between -1 and 1. And whatever you need, you multiply it. You multiply it, then you check the limit of the function to the right, function to the left, if they are the same. So the limit of the middle one is also the same. And you are done. That's it. We are done as we promised. Okay. So you have many problems to check in your practice quiz, even practice test. So you should be able to do all of them except the last one. and that would be related to the continuous function. We are going to talk about continuous function for you tomorrow, and we go over the practice quiz tomorrow. Then we are ready for the quiz 1. So study this lecture very carefully. That would be quite important for you. Okay, we did all the techniques and the methods that are going to be used in this course. Okay, make sure you understand all these 16 or 15 problems that I did, and then we practice it again for the quiz, and we practice it for the test. Then you let me know if you have any difficulty on this. Okay, continuity is very easy. It's the same thing, you know, it's just a definition. We check it so that we are done with chapter 1 for the first week, and that would be our target. You know that your first quiz is going to be posted on Friday, and it's going to be due by, usually it's due by Monday, but since this Monday is holiday, so we let you bring it back on, upload it back into the Canvas by Tuesday night. It usually do by Monday. So we finish chapter 1 nicely, and we go over those practice 1, and then we are ready for it. Okay, so again, I emphasize that I study this one carefully. If you have any question on it, come back tomorrow and just let me know. Then we are going to check this one tomorrow. Okay, any question? Again, I have a class I have to go, but in the afternoon, I will post the video, you know, the recording and this lecture note as well. Okay, take care and have a good one. Bye-bye.
Bye. Thank you.